Good day and welcome to Metron's podcast series, Round the Water Table, your source for utility and real estate water resource management knowledge. My name's Nick Bettis, the Vice President of Marketing at Metron, a leading provider of best-in-class water infrastructure and analytics to utilities and real estate companies. Today, we are joined by Metron's Vice President of Engineering, Mike Drake, and we're looking at the different types of water meter technology and their pros and cons. Welcome, Mike.
Thank you. Glad to be here.
And with that, let's just get started. So, Mike, let's start at the highest level of technology. When it comes to measuring and conserving water, there really are four factors to this. There's the meter, the register, the communication method, and the software. Is that right? So for today's podcast, we're going to be focusing on the hardware side of that, and we'll save the software for another day. So let's level set on the different kinds of technology. So historically, there's been AMR and there's AMI. So tell us the difference between those two things.
So AMR is sort of the older technology, automated meter reading, and was intended to eliminate more or less human error, right? So if you go all the way back to the beginning where somebody was coming out and physically writing down what the meter was showing for consumption, obviously that has the ability to introduce faults into that. So really started out with things like handheld devices where you could physically go up, touch, that would go down to the meter, pull serial number and read, and that way you eliminated that. That then progressed into AMI, which is infrastructure, right? So you had basically walk-by, drive-by systems in the AMR scheme. This was now hanging infrastructure, so like a gateway that would collect the radio broadcasts of the individual meters. Maybe the easiest differentiator there is AMR is one-way communications from the meter back up, and AMI is two-way communication.
Okay, great. All right, so let's talk about the meters specifically. So we're going to go through each of the different types of technologies that are used broadly today for the meters, give you a background on what they are, how they work at the highest level, and what the advantages and disadvantages of each are.
Sure.
So let's start off with a single jet. So tell us what a single jet is.
Yeah, it's a very simple device. Actually, Metron's bread and butter is our single jet line. We are the number one manufacturer of single jet meters in North America, but you're essentially just necking down the flow of water and shooting it onto an impeller, and then as that turns, a shaft connected to that impeller is then turning a magnet, which can be sensed from external or in old style registers could actually magnetically couple and physically turn the dials on that register.
Okay. And what's the advantage of that technology?
Very simple, very long lasting. Probably, the biggest knock would be just wear over time. But, Metron solved that by creating a design where the impeller will actually float at a high flow so that you're not getting that friction, which can break down the meter over time.
Okay. And historically, what have we seen for a life on these meters?
Well, we've definitely got units that have been out in the field for 25 plus years. So we feel like the body itself, the measuring unit, is very long lasting. Obviously, it's hard to get batteries and the electronics to last quite as long. But the meters themselves, obviously, I'm not sure what the oldest one is, but plenty of time.
Still going strong?
Still going.
Strong. And from an accuracy perspective, is there any concerns? I mean, how low a flow can they measure and how high a flow?
Yeah, they're not going to be the best at low flow, but I would say pretty good. We get down into sort of 1/16 of a gallon, and a lot of that water that has been unable to be billed by the utilities can now be captured and seen. We actually break that out in our SaaS platform to let people know what they're truly losing with other technologies.
Okay, great. All right, so let's move on to the next one, multi-jet. How does that differ from a single jet?
So one of the possible issues with a single jet technology is that you're only pushing on one side. So when you get a lot of variation in flow, that can be hard to track for a single jet style meter. So multi-jet, much more complex design, but you're trying to shoot that water onto the impeller from multiple angles. So it helps kind of even out some of that variability. You can think of it almost like mathematical averaging. Much more complex design, can sometimes gum up a little bit easier, but that's the theory behind the multi-jet.
Okay. Any other advantages or disadvantages to those?
No, I mean, both of those have to be horizontally installed. You can't mount them vertically because then gravity has pull on the impeller, but I think we covered most of it.
Okay. All right, so we talk about positive displacement meters. Tell us about those.
Yeah, so the easiest way to think of that technology is you're filling up small buckets and dumping it from the inlet to the outlet. So with that sort of rotating mechanism, still magnetically coupled to the outside world for sensing, but very, very good on low flow because really no water can get through unless it gets into that bucket to be dumped across to the other side. So our VN register on top of Metron's PD meter is the most accurate low flow device in North America right now.
Okay. Okay, great. Is there any orientation restrictions on that one?
No orientation restrictions. I would say maybe some of the drawbacks to PD is they can be noisy. So like if they were installed in somebody's basement, like in the northeastern part of the United States, that echo through the copper pipes is probably not something that a lot of people would be a big fan of. And then obviously there's a lot going on in the mechanical action, so they can tend to wear maybe a little bit earlier than some of the other types.
Okay. Let's get into some of the... I'm not the expert here, but maybe some of the more obscure types, a turbine meter.
Turbine meter, very very similar to a single jet or multi-jet. It's except for now, instead of the water sort of being sprayed against the paddle, think of it like a propeller from an airplane being in the water flow. So as the water flows, it's just turning that, and then that is turned into magnetic rotation on the outside of the meter as well.
Okay. Any advantages or disadvantages to that technology?
Nah. Nah.
Pretty basic, but
yeah.
I mean, honestly, I don't think I've ever seen these anymore.
Yeah, they tend to be pretty good at high flow. We've used it for our hydrant meter as an example, as a turbine style meter. So yeah, and it's one of the parts of a compound meter, the most traditional way that a compound meter is built.
Okay, well, let's talk about compound meters.
Sure.
How do those work?
So what you're really trying to do there is stretch the dynamic range of the meter. So sometimes called turn down ratio, but what is the multiplier between my low flow and my high flow? So the thought here is you're getting 2 meters in one. Very often the low flow side is a positive displacement meter. The high flow side is a turbine meter. And so in theory, you're running on the low flow until you hit some crossover. So there's a valve in there that would then redirect to the high flow side. From there, in theory, you're getting the best of both worlds. Very complex. Very often you see the valves sort of get stuck in one position, and they do tend to wear. I would say we see fewer and fewer of those over time.
Right, and I suspect, given the size of that meter, that those are more expensive than
absolutely
most of the
more
other technology
expensive.
types.
For sure.
All right, so all of those meters we just talked about are what we would call mechanical meters.
Yep.
Right. So there's another side to this. Then that's the static meter side. And the static meter essentially means that there's no moving parts, right?
Correct. Yeah, sometimes also known as electronic meters. So you're just using something other than the pressurized water to make the flow measurements inside the device.
Okay. And I think there's only two kinds that really are out there today. One is ultrasonic. That's the big one. It seems to be where all the news is around right now. I was just recently at a trade show, and it was all about ultrasonic meters.
Yeah, definitely. At least in water in North America, that's definitely true. So actually, a fairly easy device to understand. So you have at least one pair of transducers. A transducer is, think of it like a combination speaker and microphone, because you have to be able to go in both directions. So basically you have those transducers in the flow of water, and you're just sending signals back and forth. So ultrasonic, meaning just above human hearing. A lot of times it's sort of in the 1 megahertz to 2 megahertz range is what the frequency of that signal going back and forth is. But if we assume U is the upstream transducer, D is the downstream transducer, when there's no flow, the time of flight to go from U to D and D to U is equal. Mm-hmm. As water starts flowing in that downstream direction, so then U to D would get there faster, and D to U would actually go slower. So then you can back out the math to basically figure out how much flow is going through the meter.
Absolutely fascinating. Advantages and disadvantages?
No moving parts, nothing in the way. So with mechanical meters, a lot of times, right, you have issues with pressure drop. So you can absolutely use an ultrasonic in sort of fire applications where a pressure drop is unwanted. Also can be installed in any sort of direction. So for vertical installs, things of that nature, very useful.
Okay. And orientation-wise, these can be mounted vertically.
Any direction. Yep, you got it.
And sediment, there's no concern with sediment.
Correct. Just passes through, obviously, because nothing's in the way.
Right.
I would say say maybe some of you can have, depending on the type of design, sort of fouling of the
Sensors.
the interior sensors that can you can counteract some of those things with the way that you process the signals, but that can change sort of the way the meter behaves over time.
Okay. And then the second type of static meter is a magnetic meter.
Mag meters, yeah. So I would say probably less common, except for maybe in custody transfer. But essentially, the water has to have some dissolved salts in it, or minerals for this to work. But essentially, you're using an electromagnet across the tube, and then as it hits those dissolved salts that are in the water, that's creating little bits of charge that you can detect that voltage, and so the faster that it flows, the more you're building up that charge. Maybe a decent way to think of it would be like trying to measure static electricity for determining how fast a river is flowing.
Okay. So anything that's not a distilled water then still works in these then, or?
Yeah, in general. So one of the common uses is for caustic liquids and more sort of industrial process control applications.
Yeah. So for typical utility or for a mobile home park that wants to meter the pads that they're on, this is probably not
as common. Yeah, and it's pretty. There's only one commercially available residential size meter that's battery powered. They tend to be AC powered because they're a little bit power hungry overall.
Okay. So we don't see many mag meters out there anymore, right?
No.
On our side at least. So overall, it sounds to me like there's different uses or different meters for different use cases. So in situations where you got vertical mounting, maybe some sediment in the water, an ultrasonic would be a good choice.
Absolutely.
In situations where you have some room to mount them horizontally, and you need a accurate but low cost solution, any one of the mechanical meters might be a good solution.
You got it. Yep.
Cool. All right. Well, let's transition away from the meters now and talk about the registers and comm side. So, as we talked about earlier, advanced metering infrastructure is the ability to communicate this data without having to do a drive-by or a manual reading. So, tell us a little bit about the different kinds of reads. So, we've talked about manual reads already.
Yep.
That's somebody going out with a pen and paper and taking down the numbers. Lots of opportunity for error in that type of a system. What about RF, drive-by?
Yeah, so the transition from sort of AMR to AMI was really started with proprietary radio technology, right? So very often was in sort of the ISM band, which is 900 megahertz. That was the old sort of cordless phone technology. And then some people used, in general, lower frequency has longer carry. So there are some licensed band applications in sort of the 450 megahertz range. But really what you were doing once you went beyond somebody being on site was you were just barking out, here's my serial number and here's my read. Then a drive-by, you still see this in Colorado with Excel, who does natural gas for most of the state, where they go out and there's a collector in the car where they're picking that up. So from there, then the transition to AMI was instead of that data aggregator being in the vehicle, you just hung it on a light post or something like that, a cell tower, and then the backhaul would be sort of over the internet, right? So this started with sort of 2G cellular, could be a wired connection as well. Problem with that, obviously, is that you've got to hang up a lot of these things if you're doing this across an entire city. So it can become intensive in terms of the investment in the infrastructure.
And maintenance.
And maintenance, right? And a lot of people that are sort of running water utilities maybe are not RF experts, and so that can be a little bit of a challenge. What Metron did and was one of the pioneers was actually put the communications, the cellular communications, directly on the register. One of the things that obviously provides is now if I don't have to hang a gateway, and if the gateway were to go down, right, you lose however many hundreds of meters, versus in this case you lose just the single register that's offline. So I would say, pretty heavy push by a lot of the industry right now into cellular as probably the overall best technology. There are obviously coverage issues in certain areas. That's less and less all the time. Probably the only other competing technology, at least in North America right now, would be LoRaWAN, which is just a standardized version of sort of this 900 megahertz, sub-gigahertz stuff.
Right. Yeah, and I think that's a great point, too, that a lot of the utilities and the the property owners that want to have this data are not cellular experts, are not communication experts.
Absolutely.
They don't want to have to deal with how understanding where is the problem, where's the breakdown, where do I need to put the towers, all that sort of thing, and maintaining those. Having cellular, it's literally plug in, you have data the next day.
Verizon, AT&T, and T-Mobile are all very good at maintaining
that's right.
cellular networks.
Let the experts
be
experts, right?
Yep.
All right, so let's talk about communication or granularity on this. So Metron we record data on the meter at 1 minute intervals, right? But we only report it up once a day. But if there's a emergency leak or something, that will wake up and it'll automatically shoot off an alert, right?
Right.
Yeah.
Absolutely.
Yeah. So what about battery? So 1 minute data sounds like it would consume a lot of battery. So what does the battery life look like on these solutions?
Yeah, so the standard warranty in the industry is 10 years plus a prorated 10 years. So 10 years at 100%, and then it steps down to 20 years, which, off of a single D cell that's not replaceable, that is a challenge to get there. So you have to do as much of the counting as you can with the internal electronics asleep, basically. So yeah, what we're doing is basically logging at the 1 minute interval. And what that allows you to do is really see what is going on with the actual flow, right? If I'm only capturing that in, say, 1 hour buckets, I don't know how much of the audience has the experience of having to struggle through calculus, but the smaller that bucket is, the more you can actually follow the varying curve of the flow rate. With a 1 hour bucket, let's say, I really can't differentiate what happened in that hour. It all just looks like lumped consumption. So with 1 minute, the analytics allow us to basically show you the actual flow rate of the leaks. Extremely valuable. I'm fortunate enough to have a Metron meter on my house and was able to find not only a leak in my irrigation system, but my temperature pressure valve on my hot water heater was running water nonstop. So and I never go in that room, never checked that, but I knew something was going on and sort of knew where to look based on the flow rate information.
And that can be costly.
Absolutely.
And also from a conservation perspective, a lot of people today are looking to be part of the conservation movement, save water, and by having visibility into, my teenager is taking a 20-minute shower every day, maybe that's something that you can take action on. And
I have 2 teenage daughters, and I was told by one of them one time when I accused her of taking a long shower that absolutely she did not, and when I could pull it up and actually show her the graph, she changed her tune.
Changed her tune.
Yeah.
Yep. So, and all this data is getting reporting up to software, which we'll talk about in another podcast. But in this case, with WaterScope is our product that's available to both the consumers as well as the utilities or the property owners, and you can make your own decisions on how you want to use water.
Yeah, absolutely.
Yeah. So to sum things up, there's a plethora of technologies that are available from a metering and a communications perspective. And each has its advantages and disadvantages. We, as Metron, do not provide all of the meters we've talked about today. Those are conscious decisions on our part to serve the markets that we're interested in. But I think we do a really good job at it. And if you've got any questions about any of these technologies or how you can better manage your water as a utility or a property owner, please reach out to us at any time. We'll put the information on the podcast, and you can reach out and let us know, and we can walk you through whatever you might need. So with that, I think we can wrap up. Mike, thank you for your time today.
Yep, you bet. Thank you.
And we'll see you again next time on Round the Water Table.